Hear me?
Walaikum assalam. Yes, sir.
Yeah, Akib Hassan, Naushin Tarannum. Are you all here? Naushin?
Sir, yes.
Yeah, okay. Akib Hassan? Akib, can you hear me?
Yes, sir, I can hear you.
Okay, good. Now, let's come back to the point. For 9, 10 already, 5 minutes over. So before starting the class, maybe we can go for some sort of discussion from the previous section. The previous lecture, we did the Thevenin's theorem, and today we're going to go with the Norton theorem plus the Thevenin's theorem dependent source together, and this two lecture I'll upload together. And since the Thevenin theorem was not included in the midterm, I didn't go for it. Now today, I think after finishing this lecture together, we'll upload the two lectures. Now let's come back to that point. You had the midterm exam recently, so we are going to see. Check the script, and then not all. I think how many, a couple of script I have checked, and I found this problem. Actually, so far I have checked a couple of script. None of them could answer this question properly because I got some mistakes, and that's why I couldn't get the answer. So any of you have answered this one? No. Oh, can you see
No,
this?
sir,
Can you
I
see
didn't
this?
answer.
Can you see the screen? Hello.
Yes, sir.
Okay, this is the problem from source transformation. That what I have given. What happened? Student could not answer this because they couldn't get
Sir,
it.
I answered that question, sir.
Oh, okay, fine. So if you answered, you can check the answer you have done in this way or not, because I don't know I have checked your script or not. If you go with this, this is the point of the first thing you have to do of this 2 milliampere current source. If you see this point is coming up to this, and the other terminal of the current source is coming up to this thing. So what can we do? You can bring this thing here like this, the 2 milliampere current source, you can bring like this. This is 2 milliampere. You understand it?
Yes, sir.
Okay, then you can take it off from here, because this is a parallel, so it's the same node. So that means this 2 milliampere source is in parallel with this 2K. This is what
Yes, sir.
you need to understand first, and
Yes.
you have to redraw the circuit this way. And if you redraw, then this part from here to here, you have to take off. If you take it off,
Okay, sir.
then the new circuit will be like this. And this is one thing. Another thing is, now your next step is you have to combine this source transformation. What is this source? It's a current source.
Yes, sir.
You have to
Yes, sir.
convert into voltage source. Yeah, voltage source. And you can see here another current source over here. This is another current source as well. And you have to convert this current source into voltage source. This two source conversion you have to do simultaneously. There are some people, those who did this conversion, but this conversion,
Oh, no.
yeah, is prohibited, because you're going to find the value of I naught, and
Yes, sir.
I naught is going through the 12K. As I said, 12K cannot be used for any type of conversion, so this is prohibited. But this blue conversion, yeah, you can do. And if you do the blue conversion, then you can see here what will be the circuit coming, like the resistor, and this is a battery where the negative polarity here, positive polarity here, and it goes like this. And there is another conversion there, over there, the positive terminal is, okay, you can just go for resistance, then you can go for the positive terminal, then you can get your 6 ampere current source and your resistor I naught and your 4K
4.
connected here. So in parallel, actually it is parallel to 12K. This is your I naught as what you have to find, and this is your 6 milliampere current, 6 milliampere current source. And these two conversion, 6 into 2 into 4 is a 4 volt, right? 4 volt plus minus here, as you understand. And this will be a 2K. And this will be a 4K.
And 16 volt.
16 volt, right? 16 volt. This is plus minus. This is the way you have to do. Now, your next job will be, you have to combine this together, that 4 volt and the 16 volt are in series.
Yes, sir.
So you have to combine them, then 16 and 4, if you go, it is what? Actually, it is adding together.
So 20,
20 volt,
20
right?
volt.
20 volt at positive negative, and the 2 and 6, 6K. So you're going to get this thing like at 20 volt, this is a 6K, and this is a 20 volt, but 20 volt upside down like that. This is positive, this is negative, 20 volt, remember. Okay, and this is the two terminal coming here. Try to get it. This is important. This is 1, and this is the 6, and this is your 4K. This is 4K, this is your 12K, this is your I naught, this is your 6 milliampere. Okay, and this is the thing. Now you have to go for another source conversion of this thing, that is current source. If in current source, then 2 current source you have to combine together 1 current source, then your current division rule. After that, you can go for current division rule. You go from here, you can get it like this, you can get it like this, you can get it like that, another and another one. There is another one coming together like this. And these two, you have to combine these 2 current source into 1 current source. Got my point?
Yes, sir.
And then a current division rule can give you the answer directly. That's the way you can find the
Yes.
answer to this question.
Yeah, this is what I exactly did.
What is the answer you got? Okay,
Sir,
what's your name? Item.
so Jihad, sir.
Oh, Jihad. Maybe I didn't check. Sajjad Hussain. Okay, but he gave quite good marks, Sajjad Hussain. And majority condition is very bad. I don't know because of, I don't know how you can check it. That's the way we do. Okay, this is one of the question what we have discussed, and still now I think we have 2 minutes to go. So since 2 minutes to go, maybe we cannot go for any other things, but then we can jump to the class unless you have any question to discuss. Because today we are going to talk about the Norton theorem and the Thevenin's theorem, a Thevenin circuit with dependent source. And yep, that's the way we have to proceed today. Is the midterm exam already over, all of yours?
Yes, sir.
No, sir, not mine.
Most, you know, your friends, most of your friends, midterm exam is over or still having midterm exam?
I'm still having.
Still having some of them. Okay.
Yes.
All right, no problem. Now let's come back to the point. In that situation, we can start the class because we don't have enough time. We have to finish everything. Now, let's go for Norton theorem. Today we are going to discuss. Okay, before bringing that thing, I'm just going to draw the same diagram that what we have done in the last class. Last class I have done the Thevenin's theorem, and you can remember the Thevenin's theorem circuit. I have drawn a circuit like this, and I told a what is the purpose of Norton theorem, and same thing happening here with Mr. Norton. Mr. Norton and Mr. Thevenin, they are two brothers. Imagine that way. These two brothers actually uh, uh, did the same theorem. Means same theorem means the target is same, but two different way they did. I told you last class that if this is A and this is B point, and this is our LL register, you are going to modify. So what you have to do is, yeah, Mr. Thevenin did what? Mr. Thevenin had what he did is just the blue circuit, the complex circuit. He had tried to simplify it into a simple circuit. Under the blue contour, he wanted to replace it by a battery and a resistance in series. This is what Thevenin's theorem, that's what last class I told. And the resistance is R Thevenin, and the voltage source he had made it equivalent was a E Thevenin. And this is your point A and the point B. This is your point A and this is point B. This is a two-port network and B terminal. After taking out, after cutting the resistance from here, taking out, and then you are getting the equivalent circuit, which is Thevenin equivalent. This is your Thevenin equivalent. That's what last class we have seen, and Thevenin circuit. And we have solved a couple of problems also. Hey, can you remember?
Yes, sir.
Yes, sir.
Good. So in that situation, Mr. Norton is Thevenin's brother, and he was a bit jealous that how come Mr. Thevenin got such a good success, I can also do something like that. And what he did, Mr. Norton, he copied Thevenin's theorem in his head, and then he tried to find the solution in a different way. Because he thought that Mr. Thevenin made the circuit, equivalent circuit like this. He was thinking that this look like what? Hey, can you tell me? Thevenin's equivalent circuit is look like what? Mr. Norton found it in his dream that this Thevenin's equivalent circuit looks like something. Can you tell me it looks like what? What do you think? Anyone? You haven't seen this sort of thing, this sort of circuit representing what? Forgot it? Okay. None of you can remember that this sort of circuit looks like what? None of you can remember. Okay, now can you remember? Look. Can you see the circuit? Hey,
Yes, sir.
Yes, sir.
what is look like? Look like this one, right?
Yes.
Yes, sir.
So it is like E Thevenin, and this is like R Thevenin. So what does it mean? It looks like, what is this one we have started? Remember? What is this? Can you read, or you cannot read also? This is what? What is this circuit? We already started. This is the circuit of what?
So source transformation.
I know that, but this is what source?
So voltage source.
Right.
And
That is what you mean by and. It is voltage source and current source also.
No, and we going to change it into a current source.
That is separate issue. I'm asking you, what is this? Is it a current source or voltage source?
Voltage source.
Right. So Thevenin's equivalent circuit isn't look like this.
Yes, sir.
Now look at it. Isn't look like the voltage source, isn't it? Hey,
Yes, sir.
all of you, hey, come on. How can, okay, it looks like the voltage source, exactly similar to the voltage source. So what Mr. Thevenin had done, he this complicated circuit, he represented, or he found equivalence, which is look like this, which is look like the voltage source. So the voltage source, his name according to his Thevenin's equivalence, Thevenin voltage, and then resistance, Thevenin resistance. Like I'm just drawing again. We in our voltage source we have written ES, and our resistance we have written RS. This is our voltage source. Last for source transformation case I'm talking about, we have done right like this. So which is look like that. So this is Thevenin's voltage. This is Thevenin resistance. Actually, nothing else. Okay, so I think everybody should understand. Okay, now Thevenin's equivalent circuit is similar to voltage source. So Mr. Norton thing, why not I try to understand what I'm talking? Hey, do you understand what I'm talking? No. Hey, do you understand the way I'm talking? Do you understand, or you cannot understand
Yes,
it?
sir. We understand.
Okay, may I request you, Akib, can you unmute your, yeah, everybody unmute your microphone, everybody. Okay, Naushin, unmute. Okay, just whenever ask question, please answer, because I think all the microphones are not noisy microphones, are very much silent, so no problem. You can keep it unmute, and you please answer when I ask whatever you get. Now, this Thevenin equivalent, which is look like a battery, which is a voltage source. So Mr. Norton think, why not I make a equivalent circuit, similar equivalent circuit using the current source. And he did it. And he found his equivalent circuit he found, which is similar to the current source. The current source is look like this one. Current source is, I think last source transformation, we have studied the current source, RP here, IS here. This is the current source in the last source transformation. This was RP, so RP, and this one was the IS. So what happened, he said, I can also make the equivalent circuit like that, not like Thevenin. So Thevenin had made that way, I can make it in this way. And he made it, and according to his name, this one is I Norton, R Norton, and this current is I Norton. Instead of IS or RP, he, according to their name, Thevenin or Thevenin, like that way. So this is what looked like the current source, and he did it like this. And he found, yeah, equivalent circuit can be found in this way. And successfully he did it, and that's why, according to his name, it is Norton equivalent circuit. Now, what Mr. Norton did in his case, the Rn he found is exactly same like R Thevenin. So Rn and R Thevenin is same because Mr. Norton found it in this way. If the voltage source, you know, the currents RS and RP is same, like that way he did it. Now what I'm talking, okay, I'm just telling you what I mean. The Rn Mr. Norton determined the same way Mr. Thevenin determined the R Thevenin. That is the thing. So you already know how to find R Norton, because you know how to find R Thevenin. Exactly the same way you have to find the R Norton. So R Norton same as R Thevenin, full stop. That means the way you found R Thevenin, it is the same way you have to find the R Norton. How R Thevenin was found? Mr. Thevenin had taken it off and he found the resistance through this RAB. Remember last class I told you, and that is what R Thevenin. And when you find RAB, what to do with the voltage source? Can you remember? I told any source.
Yes, sir. Short circuit voltage source.
Voltage source short, deactivated. That means the voltage source should be short circuited. To deactivate it means it has to be short circuited. Good. And if it's current source, it should be open circuit like that. So RAB, now you can say this plus parallel series combination, you can find the value of RAB. So that is your RAB, which will be the same thing. That is what I'm talking about. R Thevenin we found last time. R Norton also same way you can. So R Thevenin and R Norton, you can find the same way. So there is no difference. That's why this is nothing new to you. The R Thevenin, R Norton and R Thevenin, the same way you can find. So I don't need to explain it. You can easily understand. Now let's come back only how Mr. Norton describe about the IN. Norton current, how to find it. That is the new thing to all of us. Now let us see how he found Norton current. Try to remember, last class I told, Thevenin have found the E Thevenin, which was open circuit voltage. That means the VAB, he found EAB, open circuit voltage, he found. Last class I told you how to find the open circuit voltage. Now, Mr. Norton did what? Mr. Norton, all you can understand, if Thevenin did open circuit, Norton should do what? Any children also can understand.
So short circuit.
Absolutely. That is what Mr. Norton did. He just short the two terminal A and B, and if you short it, a heavy short circuit current will flow through this. If you short the 2 point, a short circuit current will flow through this path. That short circuit current is known as I Norton, and that is what he found, and then he said this is Norton current. And the short circuit current, when you are going to find, that time this source cannot be deactivated. This source should be kept active. So this source is active now. Now because you are going to find the I Norton or V Thevenin, that time the source will be active. So if you keep the source active and it is short circuited, and we can find the I short circuit from this. How to find the I short circuit current? Can anyone of you tell me from your knowledge so far? Because you have gone for the midterm exam, you already know how to find it. Can anybody tell me what is the best method? Any of you can think and tell me from this circuit. If I ask you what is I short circuit current, then what is the best easy way? So for the method,
Sir, mesh analysis.
Absolutely good. Absolutely correct. Mesh analysis. So you are getting the mesh current 1, 2, 3, 4. There's a 4 mesh current you find, and then let's say this is I1, I2, I3, I4. And I4, this I3 you are getting here. This I3 will be the answer. Once you find the value of I3, that I3 will be the I Norton. That's it. So you can find the value of I Norton from the mesh analysis. Then you get your Norton circuit. So I Norton, the Norton equivalent, this is your Norton circuit. Norton circuit. So Norton equivalent circuit is like this, and Thevenin equivalent circuit is that. Now you all understand Norton equivalent circuit?
Yes, sir.
Okay, now look, we are going to solve some problem based on this, but before that I would like to tell you one thing very carefully. Look at it now. Look, please. This is the complex circuit which is represented by Thevenin equivalent. This is the complex circuit which is represented by Norton equivalent circuit. Means, let's say this is A is represented by, this is B, and A also represented by C. What does it mean? It means A is equal to B, right? Because this one, Mr. Thevenin had found the B from A and equivalent. So that means A and B are same. And again, Norton had found A into C. So you can say that A and C is same. A is equal to C. Now, if B is represented, A is representing by B and A is representing by C, then what can we say? C and B or B and C are also equivalent or same. Do you get my point? If A is equal to B,
Yes, sir.
A equal to C, any children didn't born, if you ask him, what is the conclusion? Conclusion is B equal to C. Do you get it? The guy will tell, yes, I understand. It is true. Do you understand, all of you?
Yes, sir.
If it is true, that is what happened. That is the source transformation. Let's go back to the first transformation class. Current source and voltage source are equivalent. So this voltage source, Mr. Thevenin, and Mr. Norton is current source. Just imagine in that way. So these two ducts are equivalent. This is what the understanding. Okay, now look at it. You remember, if voltage source and current source are equivalent, then what is the relationship equivalency? I'm just going to show you from the previous class. You can remember, and please tell me if you can remember. It is ES, it is RS, the voltage source. This is current source. Source transformation, I'm talking. One of you answered, so I think he understands much better. Okay, this is IS. So these two equivalent. What is the condition of equivalence? Can you tell me? You should know that. What is the condition? RS equal to? Hey, duck.
RP.
RP. Reply. I open your mouth. You talk. And what is the other equivalent? ES equal to? Forgot it. ES equal to what? Hey, you answer the source transformation. Some of you told.
SRP.
GRP.
ISRP. Yes,
Right.
sir.
IS.
Yes, sir. ISRP.
ISRP, like that. So, or RSRP, you can also substitute RS. So ISRS also you can say, whatever, because RS and RP is same. So RP you substitute RS, so you can get whatever RSRP. So this is the thing you get. If you get it like this, also same thing happening here. If I say these two are equivalent, and then what can we say from these two? Then we can say from these two, then this guts can be said like this, that R Thevenin is equal to R Norton, isn't it? R is equal to RP.
Yes. Yes, sir.
Okay. And E Thevenin will be what? Can you tell me?
Sir, E Thevenin is equal to I Norton into R Norton.
I Norton into R Norton. And again, I Norton into R Thevenin also, because I Norton into R Thevenin also you can say. Because R Norton and R Thevenin is same. So you can substitute. Got it now?
Yes, sir.
Yes, sir.
Okay, if it is so, then from this relationship, can we also conclude that R Thevenin is equal to E Thevenin divided by what? I Norton. Can we say this also?
Yes, sir.
All of you get my point, what I mean?
Yes, sir.
Okay, so this is the conclusion. Also, we can get from this Thevenin and Norton equivalence. These two equivalence, from these two equivalence, we can find the relationship for the R Thevenin. Remember, this relationship will be required at the end in today's class. What is that? You can see here on the top, what is written. Look at it. What is written there? Thevenin's, the second part. Second part is what? Can you read? Any one of you can read what is written in the second part? Jihad?
Yes, sir. Thevenin circuit with dependent source.
Good, you can see that. So this part actually we are going to solve. That means when the circuit is having dependent source, so far we have solved last class all independent source. Today at the end, we will see some dependent source problem, and this dependent source problem you can 100% expect in the next question when it is a class test or final exam or whatever exam. This type of question you can expect, that the dependent source problem, remember. So how to solve the dependent source problem, we will need this relationship at that time. This relationship is needed in order to solve this problem today at the end. Thevenin circuit with Norton or Thevenin circuit with dependent source. It is the Norton circuit or Thevenin is, if the circuit is having dependent source, then we need this relationship to solve the problem. That one we'll see today. But how the relationship comes, I think everybody clear. Are you?
Yes, sir.
Yes,
Good.
sir.
I think excellent. Now let us go to see the next step. Next step is our first thing first, the Norton equivalent circuit problem first. Today we'll see. After finishing, then we'll jump to the dependent source problem. First of all, last class we saw Thevenin's theorem circuit, how to solve, how to find the Thevenin equivalent circuit from a complex circuit. We saw last class a lot of example, couple of examples we have shown you. Today we are going to see the same fashion. We are going to see this complex circuit can be converted or can be determined into Norton equivalent circuit. So we are going to see today this thing. Now let's go there and let's go for that part. If you go today, 12, lecture 12. Okay. Now if you look, I think it's already uploaded and student, anyway. Now this is what the Norton theorem, what we have discussed. All right. You can see the Norton theorem said that any two-terminal linear DC network can be replaced by an equivalent circuit consisting of a current source and a parallel resistor as shown below. This current source is known as I Norton. This parallel resistor is known as R Norton. And this guy is Mr. Norton, brother of Mr. Thevenin. And he found very easily Norton equivalent circuit. Because Thevenin equivalent circuit, understand, equivalent voltage source can give you this information. I think you all understand this thing so far I have explained. Everybody clear about it?
Yes, sir.
Yeah, this is the equivalent circuit, Norton equivalent circuit of any complex circuit. That's what I have told you. And next thing, if you see, then you can see the next picture gives you the similar thing. But here, if you see there, what you can see, the additional thing is coming, which is this part. It's the same picture, but this is the additional thing. What is this? This is what I already shown you, that if the complex circuit, if the equivalent circuit replaced, the DC network can be replaced by Norton or Thevenin, then these two are equivalent. That is, Thevenin and Norton are equivalent. And the relationship also shown here. If you see the relationship, R Thevenin equal to R Norton, they have also said the same thing. And E Thevenin equal to R Thevenin, or this is the thing. So ultimately from this, the relationship we have already found, which is going to be used, is R Thevenin equal to E Thevenin divided by I Norton. This thing actually described over here. So these two slides are giving this information. Actually, this is our main target from these two slides to derive. I already discussed it today at the beginning in the last slide. You all clear up to this, right?
Yes.
These two slides, good. Now we are jumping to the next step. That is Norton equivalent circuit, how to find. Now, if you look at this doc, first problem we are going to solve. This is, then you can understand step by step. Hey, anybody got any questions so far? Otherwise, because we are jumping to the solution to the problem number 1, that is how to find the Norton equivalent circuit from a complex circuit. All of you okay? Should I go?
Yes, sir.
Okay,
Yes, sir.
no problem. Now look at it. If I say find the Norton equivalent circuit for this circuit shown, that means this is the blue thing. Blue circle means, you can see here, I have shown you here. This is the blue circle. Look very carefully. This is the blue circle, the blue contour. This is a blue contour. That means the circuit inside the blue contour, we found the equivalent, a Norton equivalent is like this. And how? We find the R Norton, that is like the R Thevenin we found exactly the same way. And we will find the R I Norton. How to find the I Norton? We'll short the AB terminal and find the short circuit current. And that is, these are the two things we have to find every time. So that is the way we find the Norton. So this is the blue contour. Now we have to find the, so blue contour means we have to take it off, and then it is going to be A terminal and B terminal. So if you go for Norton circuit, the Norton circuit will be like this. Norton circuit will be like this. Okay. Ting, 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 ting. Then it is the Norton equivalent circuit. So your A and B will be here. Okay, this A and this B I'm talking about. A and B here. Then this will be the Norton, I Norton, and this will be I R Norton. Full stop. Now all what you have to do is you have to find the value of R Norton equal to what? And I Norton equal to what? That's it. You got the answer. You got full marks. You got a clear idea about your EEE 201. Instead of jumping to others and don't coming to the class, or this, or a loser, I don't know. Okay, I'm just wondering about now how to find the Rn from this circuit. Can you exactly same like what you did for R Thevenin? That means if you look through this RAB, you have to find RAB, that will be the R Thevenin. If you look through this, and what to do with the voltage source?
So short circuit.
You short circuit this one. If you short it out, then what will be the RAB value?
Sir, 2 ohm.
How you found 2?
So 3 and 6 are parallel.
These two are parallel. Do you all understand? R1 and R2 will be parallel if you short the battery?
Yes, sir.
Good. If you understand, please tell me if you don't get it. So RB is nothing but R1 parallel R2, which is nothing but 3 parallel 6, and 3 parallel 6 is 2 ohm. So here a friend said this is 2 ohm. So the answer is 2 ohm. Okay, 50% marks you get. Another 50% marks remaining for the I Norton. So how to find I Norton? I told you already in the, hey, anybody can tell me how to find the I Norton?
Yes, sir. Source transformation.
Hey, come on, dumb. Akib, I think you are talking to your girlfriend, is it, Akib?
No, sir.
Then what's wrong if you keep the mouth open? Gaurav Shah, you just come, you don't know. I told everybody to keep your microphone on so that you can answer to my question immediately. So everybody should keep your mouthpiece on unless it is making any noise sound or something like that. Noise, then you can close it. I see everybody is okay, all are silent. Because you need to instantly answer to my question. That's the reason why. Now let's come back to the point. Now, how to find the I Norton? What to do? Can anybody tell me? To find the I Norton?
So source transformation.
No, look at it. I'm showing you here. To find the I Norton here, what I did here. A and B was, A and B what I did?
Short circuit, sir.
Short circuit. Because Thevenin's equivalent you found, E Thevenin, from the open circuit voltage, EAB. Now, Norton case, you have to short it and find the short circuit current, that is IN. So to find the IN, you have to short the terminal A and B. Got it now?
Yes, sir.
So A and B terminal, what I mean is A and B terminal will be shorted. This is short circuit. This is shorted. If you short the terminal A and B, then, and R Thevenin we have found already, R Norton, so we delete it, you all understand it. Now, if you short it, then you can see a short circuit current will be flowing through this. So if the short circuit current, which is I short circuit, which is nothing but I Norton, we have to find it. What? That's what the way we can find. And in this case, you have to keep the voltage source active, not deactivate. All of you understand?
Yes, sir.
Yes, sir.
Now tell me, what will be the I short circuit current? What will be the current flow through AB terminal? One thing I'm telling you, this 6 ohm resistor, that means from here, if you short it means it is shorted from here, right? It is shorted from here to here, isn't it?
Yes, sir.
Okay, that means what? That means across the 6 ohm resistor, 6 ohm resistor is something like this. It means what? 6 ohm resistor, if you short the 6 ohm resistor like that, the 6 ohm resistance will be redundant, isn't it? Will there be any current flow through 6 ohm resistor?
No, sir.
No,
Right, because it is short circuited. This is same thing, because 6 ohm resistor actually short circuited. The 6 ohm resistor is short circuited. So it is redundant. It is dead because no current will flow through 6 ohm resistor. The current coming, look at it carefully. These are the basic knowledge, and if you don't have basic idea, your whole life will be a disaster, because you enter into the EEE department, your basic is not clear, you'll be in trouble. Look careful. This current coming from the battery, that current will go through the short circuit path and coming here. No circuit, no current will come through the 6 ohm resistor, 0 ampere, because the 6 ohm resistor is short circuited. So the current will go through the short path. No current will go through 6 ohm resistor. Everybody understood?
Sir.
So the circuit,
sir.
yeah, circuit is pretty much look like this actually. Full stop. Got my point now? So this is your 3 ohm, this is your 9 volt. So if I say what is I short circuit current, what any children didn't born, if you bring him here, he also can answer what is I short circuit. Tell me. You tell me what is the
Yes, sir,
current flow
3.
through this circuit. Yes. How you found 3? Dream.
E by R, sir.
That is what you
V by
have.
R.
V by R. V is your 9 divided by 3. 9 volt, 3 ohm equal to 3 ampere. So your short circuit, it says this is what? 3 ampere current is flowing through this. Because 9 ohms law direct. All right, everybody understood it.
Yes, sir.
Then what your answer is, the Norton current will be here 3 ampere. 3 ampere. So 3 ampere Norton current and Norton resistance is 2 ohm. So that's the way you can get the simple answer. This is the equivalent circuit for the Norton theorem. Now this is how we can find. Anybody got question? Please let me know. If you ask question, then it will be clear to everybody. Otherwise, all are sleeping. Okay, now this is the second problem. Here again, the same thing. If you look at the blue, just shaded area is the blue contour. The complex circuit is this one. Now you have to find the Norton equivalent for this circuit. Norton equivalent means I Norton, then the I R Norton, and your A and B is here. A and B. This is your A and B. Okay. So what to do? You cut it off first, take it off, and then find the R Norton first. R Norton equal to what? then you find I Norton equal to what? That's it. So R Norton, which is very similar to R Thevenin, and that one I told you already, that one you have to look through this and find the value of RAB. Just now you have found one. Provided the source should be, the independent source should be deactivated. Are there any independent source in the circuit? Come on.
Yes, sir.
What is that?
Yes, sir.
10 ampere current source.
Good. 10 ampere current source. How to deactivate it? Short circuit.
Open circuit.
Good. If you say short circuit, then your brain shorted. Now open circuit. So you just cut it. Open circuit means you just cut it. Take it off. Then there is no connection here. In that situation, anybody can tell me RAB equal to what? You cannot
So
tell
4
me,
plus
you
5,
worse than a
9.
children. Yeah, 5 plus 4, R1 plus. These two resistances are in what? Parallel.
Yes, sir.
Yes, sir.
Series.
Ah.
Series.
Yes, sir means what? Okay, this R1 and R2 will be in series, means they are adding together. That means it is going to be 4 plus 5 or 5 plus 4, whatever you say. And that gives you 9 ohm resistor. So R9, 9 ohm. Hey, I don't understand. To ask you, you understand or not? Everybody should understand it. You all okay? I'm jumping now to I Norton now. Is it okay now?
Okay, sir.
Okay, I'm
Yes, sir.
deleting this part because you all understand it. Now, if you want to find I Norton, what to do? What to do to find I Norton? Remember, A and B terminal should be
Short circuited.
short circuited. That is the way. You have to short the AB terminal. This resistor will be shorted. AB terminal will be short circuited. Now, if you short circuited this and then you find the current, I short circuit current through this I short circuit, that is your I Norton. Now, what will be the I short circuit current? That is the question now. And in this case, the current source should be active. Now, what is the current flow through these? That is the case we have to go for. Now, this current, actually this current flow through this, and then coming through this. This is your short circuit current. So what will be, anybody can tell me how to find it?
Yes, sir.
What is
A
that?
super mesh.
Okay. So what do you mean by super mesh? You don't need to go for mesh analysis here. You can straight away find it. One easy way you can do, anybody can tell me what is the easiest way? One guy said super mesh. Fine, at least he got some idea. And none of you got idea, any other thing. I assume super mesh, you can do it, super mesh, but you don't need to go for some complicated mesh analysis. You can do it easy way.
KCL.
What is that? KCL. Okay, now that means you're talking about node analysis. Somebody said mesh analysis, somebody said node analysis. Okay, node analysis will not be the best option. It's straightforward, it's simple circuit. Any other idea? There
Sir,
are two way you can do it, straightforward. What is the two method? Yeah, tell me what is that? Anybody can get. Yeah, sir, what? Tell me.
sir, source transformation.
Okay, fine. That's what I wanted to know. At least someone should send me some answer. Yeah, one is source transformation. It's one easy way. So that is this one is a current source. You convert into voltage source. Then how the circuit looks like? The circuit will be look like this, the voltage, and this is the resistance, and you are getting the AB short circuit is there. So I short circuit you are going to find here. So your 4 ohm, this is your 5 ohm, and this is your plus minus, and 10 into 5, what is that? 50 ohm, right? 50 volt. Do you get the source transformation? Hey, all of you?
Yes, sir.
Okay. Now it is, you can close your eye, I can find it like this. What is that? 50 divided by 4 plus 5, right?
Yes.
What is that? 50 divided by 4 plus 50 by 9 equal to what?
5.55.
5.5. Another 5.
So 5.56 actually.
Okay, 5.56. Okay, no problem. 5.56 ampere you are getting. So this is one method, one way you can do straight away. You don't need to go for super mesh and all node analysis also. Straight away. Another way is, can you tell me what is the other way? These are the basic knowledge you have to have. Another way. Okay, the other way is you can go with the current division rule. The current division rule, if you can see like this, that you can imagine it is a very simple circuit like this resistance here. This is 5 ohm, and this is current is 10 ampere. And these two terminal A and B, you can make the 4 ampere resistance here, 4 ohm resistance here, and this is going to be your I short circuit, right?
Yes, sir.
That is the current flow through 4. So current division rule, total current divided into two parts. I am going to find I short circuit part. So what will be the I short circuit current division rule say? I think every children should know what is this I short circuit equal to. Can tell me I short circuit equal to what? Equal to what? Current division rule say what? Remember, total current. Hey, what is the current division rule?
So total current divided by 10 by 5 plus 4 into
Excellent. 5 plus 4
5.
into opposite resistance. Opposite resistance is
Resistance.
5.
for opposite resistance 5. And the answer is 5.56. It's giving the same answer. So either this way or this way. You understand it? Hey,
Yes, sir.
brain short circuited. Okay, both cases are giving you the same answer. You don't need to go for super mesh and all these things. You can go easily to solve the problem. All of you clear or need to discuss some more things? It's okay?
Yes, sir.
Okay, I'm just asking Noshin Tarannum, you are very silent. You understand what is going on, or you are busy with
Yes,
something
sir.
else? Okay,
No,
good.
no.
Okay, just response. Okay, now let's go with the next problem. That is this one. If you go, we are going slowly the complex. We are going towards complexity instead of initially going to the complexity. That's what I saw in the Thevenin's theorem. All brains are short circuited when go for. But now I think step by step we are going. So today you will understand it much better, provided you all are concentrating here. That reflect when the lecture you listen separately, you can also understand it clearly. So in the class you cannot, I don't think separately also can't understand. Now look at it here. We are going to do the first part, not the second part. Second part you can do it by yourself because that is Thevenin equivalent. You can do it, or you can do it also, no problem. Now look at it. Here we are going to go for the Thevenin equivalent or Norton equivalent for this shaded part. That shaded part A and B, we are going to find the Norton equivalent for first thing. If you read the question, then we go for the second part. The first part we are going to do is finding the Norton equivalent for the blue shaded part, which is like this. A and B. Yeah, you have question, can ask me. A and B. This is your A. Hey, look, this is your A, this is your B. So A and B terminal, we are going to find the Norton equivalent. Always upside arrow and down. This is the R Norton and this is the I Norton. This is always the equivalent for this one will be like that. And this part, the right-hand part of the network, they didn't ask to do anything. Forget about that part. You can just cut it here and take it away. This part you take away. Okay, just like in Norton or Thevenin's, when we RL you take out, like that way you have to take it out. Only the shaded part equivalent, Norton equivalent we are finding. After that, this blue, the green circuit will be adding here at the AB terminal. That's it. Hey, you understand what I'm talking?
Yes, sir.
Okay, assume the green circuit is disappear. Now, what will be the equivalent for the shaded blue circle circuit? Now, we are going to see that one. Okay, you want to find exactly the same way you have to go. First thing first, what is the first job? What do you find first, RN or IN?
RN.
Good. So our target is to find what is the value of Rn. If you want to first find Rn, then you look through this window, RAB window equal to what? You know that. When you want to find the RAB in the blue circuit, blue contour through the AB window, then what to do? Are there any sources inside? Hey, come on. Are there any sources?
Yes, sir. Two sources.
Two sources, one current, one voltage. How to deactivate them? You have to deactivate to find the R. How to deactivate them? The 7-volt
On short,
source.
on open.
Yeah, the 7-volt
Yes.
sources should be shorted and this one should be open. You understand it? Yeah.
Sir.
Now, Naushin Taramnum, can you tell me what will be RAB? What do you think? The 4 ohm resistor and 6 ohm resistor, the two resistance there, they are in what? Series or parallel?
Parallel.
Parallel. If it is parallel, then it will be 4 parallel 6. Can anybody tell me from this calculation?
2.4.
2.4.
Okay, 2.4 ohm. So your Rn is 2.4 ohm. Very easy. It's a very straightforward and very simple. Now, next job is what? Next job is short circuit and find the short circuit current. AB terminal should be shorted and you have to find the short circuit current. And in that case, these sources should be active, not deactivated. So I'm going to draw it again, then it will be easy. And in the exam, you have to draw, remember. So it is the way we can say, okay, there is the thing coming. Okay, this is the A and B terminal. This is all about the circuit. A and B is a circuit. And this is your coming down, which is 8 ampere. This is your 6 ohm. This is your 4 ohm. And this is your 7 volt. Okay, so this is the circuit we are having. And what we go for I Norton means short circuit. That A and B will be short circuited. That's what, and you have to find the I short circuit current. That's what you have to draw in the exam. Hey, you understand it?
Yes, sir.
Okay, if you understand,
Yes, sir.
then your job next is to find the I short circuit. Can you do it? Yes. How to do? What do you do first? Can you tell me, anybody? Anyone?
Short circuit the voltage.
No, why voltage short circuit? Because of you're not finding Rn. Rn, when we found RAB, that time we have shorted and we have opened the current source. We have shorted the voltage source. You have to deactivate the sources. But now, when you find I short circuit, you cannot deactivate the source. You have to keep the source as it is. Leave it as it is. In this circuit, if I give you this circuit and I tell you what is I short circuit current, you cannot deactivate anything. You should keep it as it is, but only the thing you have to do. Like you understand it. I hope that you got it. What is the method? What are you going to apply first to solve it?
Sir, source transformation 4 ohm
Okay,
and
okay, fine. That is
7 volt.
that is a good idea. You can go for source transformation also, and if you go for source transformation, then what will be the new circuit after source transformation? That's the voltage source will be converted into current source in parallel with this, right? So this is the 4 ohm resistor, and this will be up arrow or down arrow. Hey, come on. What is the value?
Sir, up arrow
Right,
7 by 4.
7 by 4. 7 by 4, you have a calculator, tell me.
1.75.
1.75. 1.75 what?
Ampere.
What?
Ampere.
Ampere. Okay, 1.75. I'm writing it again. Okay, 1.75 ampere. What is going on? 1.75 ampere. Okay, 1.75 ampere current flow, and this is your 8 ampere is going down, 8 ampere. Okay, and then another resistor, 6 ohm resistor is there, and your short circuit current is there. I short circuit. Okay, fine. Now it is okay. Hey, all of you understand it?
Yes, sir.
Okay, good. If you understand, then what should be the thing happened? You should combine these two source current source. You have to combine them, two current source into one current, right? If you add these two current source are parallel, so you can combine them and make one current source, and that will be upward direction or downward direction?
Downward.
Downward.
Downward, because 8 is more than that. So one resistance is a 4, another resistance is a 6, the 4 ohm, 6 ohm, and this is your short circuit, I short circuit path, I short circuit current. Now you said this is downward, out downward, this is going downward. What is the value of the current source? This is 8,
6.25.
what, 6.25,
25.
6.25, right? Good. If it is 6.25, okay, I'm writing 6.25 ampere over here. So you can see here, can anybody tell me what is the value of I short circuit now? Anyone?
Yes, sir. 6.25 ampere.
Excellent, good. 6.25 ampere. Okay, all of you agree?
Sir.
Yes, sir? You got my point. Why? Okay, you told me 6.2. Can you tell me, explain to everybody, because everybody's brain short circuited.
Yes, sir. There is a short path, so no current enters through the resistor.
Absolutely good, because 4 and 6 ohm resistances are short circuited. There will be no current flow through the resistances. But still the answer is wrong. Anybody can tell me what is the right answer? He is almost correct, but still there is a little bit error. Are there anyone
Sir.
here who can tell me the answer?
The current direction, sir, minus 6.25 because it's going to the
Then
opposite
why
direction.
you said plus 6.25? It should be then.
Sorry, sir.
Yeah, this is minus 625, right? The direction of the current. That's the only difference, because the current is flowing in opposite direction. That's why it is minus, not plus. So your I Norton, your direction is same, I Norton direction is same, everything is same, but you have to write here minus 6.25 ampere. So this is the correct answer for your question. Hey, all of you understand it?
Yes, sir.
Good. I hope that everybody should understand. Okay, the second part you can do by yourself. Second part is using Thevenin's theorem. So you can easily do the rest of the Thevenin's theorem. Okay, this problem I will be coming back after solving the next problem, because this is a dependent source problem. So I want to solve the dependent source problem first with another example, and then we'll come back to this one. Now, so far so good, because after this dependent source there is nothing. This is the end of the Norton theorem. So we want to go with the dependent source problem first, and then we'll go back to that problems in the slide, which is also dependent source in Norton. So first of all, we'll see the Thevenin's dependent source problem, then we come back to the Norton Thevenin's dependent source problem. You remember last class? Hey, last class I told you what? Remember lecture 11. Okay, lecture on Thevenin. We have gone through last. Hey, can you see the slide? Can you see? Yeah, but we didn't complete it last class. But last class, if you see, there is a thing, problems with dependent source. That is what the remaining thing, and that is what we are going to go with. And that thing I'm going to do now. So all of you first, there is no slide for this. So all of you have to, what you call that, all of you have to copy the problem I'm going to show you or draw here. All of you please copy the problem first, and then we will solve the problem step by step. The problem is like this. All of you please copy the question first. Remember, the problem with dependent source, the problem one, number one, we are going to solve fast today with the dependence. The very, very important, this is what actually you have to prepare for. A question will be coming on this type of thing every time in future you will face. Okay, now problem is this. If it is a voltage source with a plus minus voltage source and a resistor is connected here and a dependent source here as well. Okay, and if it is 2 kilo, and this is assume that what you can say is a 5 ohm, 5 volt, 5 volt, and this is, okay, I'm just going to write it plus and minus, and this is 3. I didn't write like that anything yet, so you don't need to go for it. Okay, this is down arrow. These are dependent sources. Okay, dependent sources. Okay, now this is the resistance. A and B is here. So this is your A terminal, this is a B terminal, and this is 25 ohm resistor, and this is 20I. 20I. Okay, 20I. Okay, this is 20. Now, what I'm going to go for is the blue dot here, black, I think with the orange tuck, orange or green. Okay, I'm writing here, this is I, and this is the voltage across this is plus minus, is a V is the voltage. Okay, the V is the voltage. 20 up, 20. Right. Now 20 here, I'm writing here 20, 20. Okay, 20 I am here writing 20 I, and this is 3V. Yeah, I write it here, plus, so that all of you can get it properly. Okay, there's a blue dot is a plus, minus, this is V, this is V to 3V, 3V. So you all get it actually, the question. What you have to do is you have to draw the equivalent circuit of the whole thing. So Thevenin equivalent, the whole network, you have to draw the Thevenin equivalent of this thing, that is Thevenin equivalent of this cut, A and B. So this is your plus minus E Thevenin. This is your R Thevenin. So you have to find the value of R Thevenin equal to what? And E Thevenin equal to what? That's it. So this is your question. Find the Thevenin equivalent. Find the Thevenin equivalent. I'm just writing it in short. So if this is the problem, you can see the, hey, have you copied?
Yes, sir.
Yes, sir.
Yes, sir.
Good. Now, if you look at the question, in the question, it is shown here, these two are dependent source. The 5 volt is the independent source, but these two dependent source are making trouble. So these two dependent source are present in two different part of the circuit. This is a hybrid model of a transistor. You'll come to know later in future when you go for electronics course, then you can see. So these two circuit A and circuit B, for example, this A and B two part of the circuit, but there is no, hey, can you tell me what is the current flow through this? Hey, come on. Will there be any current flow or not? No idea. Okay. If you connect this line, then you can say, yes, it is a closed path, so the current will flow. But if you don't, then it is open path. So no, current cannot flow in one line. If the current need to flow, it required to complete the path. It's a closed path. Is it a closed path? No. Because start and then go to that side, right? It can never come back. If never come back, it's the open path, open loop, not closed loop, not closed path. If it's not closed path, current cannot flow. So this current will be 0 ampere current from this to that. But if you connect it here, then it is no more 0. There will be current flow through this. You understand it?
Yes, sir.
Yeah,
sir.
but it is a open path, so there will be no current flow through this path. So you write it or not write, same thing. So I'm not writing, but you keep in your head. But what happened, A and B, two part of the circuit, but A and B, they are depending on each other. That's why that is the linking part. What is the linking thing? This linking thing is circuit A, 3 volt, this depends on the voltage of the circuit B, that is V, right? Try to get my point. Okay, this left hand side circuit 3V, this where the blue V comes from. Blue V is coming from the right hand side circuit, right?
Yes, sir.
Yeah. And again, the right hand side dependent source 20I, the green I, where the green I should come from, where it comes from the left hand side. Yeah, current I. So this is the way they are handshaking each other. That means they are dependent on each other. This linking, these are the things I and V are actually linking these two circuits together. That comes from this transistor hybrid model, as I told you. So you can say that these are together in one. These are together in one complete circuit actually, because these two V and I are linking to each other. That's the complete circuit, you can say. So we are going to find the solution to this problem. We are going to find the Thevenin equivalent of the whole big black contour, black circle. You can see the whole circuit, complex circuit. We want to find the Thevenin equivalent of it. So how to do it? This is the question. Normal process we cannot do, because in this problem, we can see the presence of the dependent source. If the dependent source is not present, then you could do it. But since it is present, so normal method we cannot do. What is normal method? Normal method is among the R Thevenin and E Thevenin, which one you normally find first?
R Thevenin.
Absolutely good. R Thevenin we used to find first. So far we have seen like that. R Thevenin, R Norton, both are same, we should find first. So you have to find RAB first, and RAB equal to what from here? All you can find it provided the sources are deactivated. This is independent source deactivated. So one independent source, maybe 5 volt, it can be independent, it can be deactivated by shorting this thing. But what about these two duct? These two duct you cannot short it because they are not independent, they're dependent. That's why you cannot find the RAB. So when the dependent sources are present, that time RThevenin will not be the first option. You cannot find the RThevenin first. Rather, other way around. You have to find the VThevenin first, then you find the RThevenin. You understand? It will be opposite. Hey, you got my point?
Yes.
Okay, good. Now we are going back to the, so RThevenin or RAB we cannot find first because of the presence of dependent source. If the dependent source is present, then RThevenin cannot be determined first. Then other way around, EThevenin will be first, RThevenin will be next. So EThevenin, how to find? EThevenin is an open circuit voltage. That is, EThevenin is what? This one, A and B. There is the V and A. This is EAB. Last class I told you, EAB, the open circuit voltage. You have to find the AB terminal voltage. If you connect the multimeter, you get the voltage. That voltage will be the EAB voltage. But how to calculate it from here? That is our question first. After that, we will find the RThevenin. Now, how to find EThevenin? That is a big challenge now. All of you concentrate carefully. Okay, anybody can tell me what will be EAB? EAB will be what? EAB will be the voltage across 25
25
ohm.
ohm.
Good. So 25 ohm. What will be the, if I say the current flow through this here is I, for example, I 25. So it will be what? 25 into the current, which is I25, the current flow through 25 ohm resistor. That's it. Now, what will be the I25? That's a question. Can you tell me what will be the I25? So 25 times, what is the I25 then? The current flow.
I/2.
Not from there. In the circuit, in the circuit.
So 20I.
Yes, this is the current flow through this. 20I current source current is flowing like this. You got my point? This is the loop current. What is the value? This current is flowing from the current source. What is that current? Okay, don't forget about, I think you are all confused. Look at it, forget about this thing. I'm just talking about 25. This current also, I'm just taking it off. Okay, so you just imagine that there is a 25 ohm resistor. And this is the thing. Okay, now if I ask you, EAB will be what? EAB will be the resistance, Ohm's law, 25 ohm resistor into current. What is the current flow through the circuit? This black path. The current will be coming.
20I.
Excellent. So now, dark people, all you understand it is 20I because the current coming from, absolutely, I'm very much wondered. Anyway, now look, now you understand 20I. Okay, good. At least you understand 20I. I am writing the green I so that you can understand. And 20 I am writing with the blue, I'm sorry, with the red 20. Now you understand where the 20I comes from, right? Hey, Tamanna, what do you call? All of you get it?
Yes,
What I'm
sir.
talking? Okay.
Yes, sir.
All right, no problem. So is it correct? Still there is something wrong. Because VAB is, this is plus and this is minus VAB. So 25 ohm times the current, that current is going in the opposite direction, right?
Yes, sir.
So what will be this? If the 20I current arrow mark is in upward direction, then you could say 25 into 20I. But the current flow in the opposite direction, downward direction, but your voltage polarity VAB is positive here and negative here. So it will be 20I or
Minus 20.
Minus
minus
20i.
20I. So this is the concept. You should understand the current flow is, you understand my point? I'm talking about if the direction of this 20I upward direction, then 20I, the current flow is upward direction, then 20I into 25. Associate law follow means it's a positive. But now current is in opposite direction, right? It is following. So it should be negative 20I because current is in opposite direction. So I think everybody understand it. Now, what is the answer? Multiply, what is that? Minus 500,
100.
500I. Now, this I you have to substitute. Where the I will come from? I will come from this one, from this circuit. Got my point?
Yes, sir.
Okay,
Yes, sir.
this is your I. So I will be what? I will be, anybody can tell me I will be what?
5 by 2.
I will be equal to, yeah, tell me what is that? 5 by 2. 5 volt divided by 2 kilo. All of you agree? Open your mouth, yes or no?
Yes, sir.
Yes, sir.
Sir.
But anybody said no,
No,
sir.
sir.
Yeah, then you tell me what is the answer then?
Sir, 3 volt is also there, so
Hey, come on, 3 voltage, 3 V. V is the voltage. Is it voltage or is a variable? Look at this. This is the variable V. This is not 3 volt. 3 volt is 3V capital V, 3 volt. Is it 3V? Or this is 5 volt. But this is not 3 volt. 3, this is the variable voltage across this terminal. This is plus minus V. This is V. And that is not, okay, this is, I'm just deleting. This is 5 voltage. This is just 5 I'm writing. You just understand. This is 5 voltage. Okay. Okay, 5 volt and this is 3V. So, okay, fine. You are telling like this. What he said, your friend, at this point, this 2 point, volt potential difference, because this is 5 volt and this one is 3 what? Not volt, 3V. V is the
3V.
variable. Yeah. So this is 5 volt because from here ground respect to ground, it is 5 and this is 3V. Will it be 5 divided by 2K?
no, sir. 5 minus 3V divided by 2K.
Yes, somebody told 5 divided by 2K. This is very, very sad. I'm talking about this is the problem. The basic knowledge. Okay, now you see, understand it. 5 minus 3V divided by 2K. 2K means what? 2000 ohm. I'm just writing here 1000. That because it's a 25 ohm written, so better to go with the voltage. Now, if I is this, hey, you clear?
Yes, sir.
Okay, I'm just
Yes.
going to delete it and write it in the blue V, then you cannot be confused. Okay, now what you do, you substitute this I into this equation. And if you substitute into this equation, then what you get is 500 into I means 5 minus 3V. 3V divided by 2000. Okay, 2000. Now 2000 cancel out. What is the value? Hey, what is this? 4, isn't it? You understand it?
Yes, sir.
Okay. Okay, now you tell me, if I leave it to you, you find the value, then it could be better. If you don't tell me, then I'll let you know that I'll ask you to solve it by yourself. Otherwise, you have to tell me what is the answer. Okay, what is left? 3V is there, right? V should be here, right? Hey, got it?
Yes, sir.
This part you understand, or you also cannot get it. 5 divided by 4, 3 divided by 4. I have written like that. Should you understood it?
Yes.
Yes, sir.
Okay, now listen. This is small v. This is small v. you look carefully. This small v, where is that v? That v is here. Can you see the v is here? Can you see?
Yes, sir.
Yes,
Okay.
sir.
And this is EB from here to here. Is this EB? So what is the relationship between the V and EB? Anybody? EAB. What's the difference? Which one is greater? Hey,
So
answer.
same, sir.
Same. Excellent. And you all have to understand that this EAB and V is same, isn't it? It is the voltage across 25 ohm resistor. EAB is the voltage across 25 ohm resistor. Small blue V is also the voltage across 25 ohm resistor. So these two voltages are same. Understand it?
Yes, sir.
Good. So I'm writing here, this is small v. Okay. So what can I do now? I can replace this v. Okay. I'm replacing this v by the EAB. Can I do this?
Yes, sir.
Good.
So
Now this EAB, it is there, ting 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 here, right? Up to this. This is the area. Okay. Now if I go for this is EAB. Now what is EAB? Can you tell me now? In this equation we can find only the EAB is unknown. Anybody can tell me? I think I don't need to do it. You can tell me, but faster. That is what you can say. Anybody? What is the answer? You cannot do it. You are not a student.
so 0.71.
Better you take a stand gun and shoot yourself and save the world from you. Anyone else?
0.71. 0.71.
All of you?
Minus 0.71.
Oh, come on. Is it like that? Really?
Yes, sir. Minus 0.71.
Oh, I'm sorry. Then something wrong there. Oh, I'm sorry. Yeah, you all are correct. But I have made a mistake here. Can you see where is the mistake? It should be what? It should be plus here, right?
That's 3 by 4.
Yeah, this minus and this minus, you multiply, you are getting plus. That's a mistake. Okay, now can you do it again? I'm sorry. Go ahead.
Okay, sir.
Redo it. What is that answer?
Minus 5.
Minus 5. Good. So all of you can check it is a minus 5. So minus 5 volt. EAB means E Thevenin, right? So your E Thevenin is here. We can get the answer as minus 5 volt. So your 50% answer is done. All of you understand? Hey, Thevenin is EAB, open circuit voltage. That is what we started in last class. And EAB we found now minus 5 volt. 50% of the Thevenin equivalent is done. You clear? Anybody got question? Or if no, then we'll jump to our Thevenin. What do you think? Should we? What happened?
Okay, sir.
Okay, good.
Okay, sir.
Now, let us go to the next step. What is Thevenin? So go to Thevenin. We have to, what I'm doing, I'm going to find the value of Thevenin. As it will tell you that first thing first, then second. Now listen, Thevenin we are going to find. Okay, first of all, we can draw the circuit. Circuit was like this, and then this is the, you have to redraw the circuit for Thevenin. Okay, this one, and then this thing. Just don't draw first. Let me draw and show, then you can draw it. But first, can you just check, tell me what is the thing I have written here? Did I write it properly or not? You just tell me. Okay, this is what plus minus 3V. Okay, this is downward direction 20I. I was going this way. Now I don't collect, I write in color. All red color can be understood. 5 volt. This is what, 25 ohm. And there's a plus minus V, V, okay? And this is your A and B. Is it the circuit look like or anything else? Is it okay? Hey,
Yes, sir.
check it. Okay.
It's okay, sir.
Okay. Then if it is something like that, then we can say that this is just, I'm writing here V minus, and then V is green V. So it should be fine. Now, when you are going to find the RThevenin, as I told you, if the dependent source is present, then RThevenin you have to go, find in the second stage. First is VThevenin. You already found VThevenin, now RThevenin. Now remember, we have found the RThevenin equation today earlier when I show you the here, look at it. Can you remember? This is the relationship. Hey, I told you,
Yes, sir.
yeah, I told you earlier as well that this is the relationship. Remember this relationship we developed today, and I told you this relationship will be used for, Thevenin circuit with dependent source. And this is the equation R Thevenin we are going to use. E Thevenin by I Norton. I think everybody can understand what I mean. Let's go. Let's go. So R Thevenin is now, equation is E Thevenin divided by I Norton. That is what we are going to use there. Now, look at it. Hey, ducks. What is the E Thevenin? Already know. E Thevenin equal to what? Hey, can you tell me?
-5.
Minus 5.
Minus 5.
Already we got, this is minus 5 volt. Only we have to find the I Norton. If you can find the I Norton, you can find the value of R Thevenin. Very straightforward. 50% already done, another 50%, that is I Norton. You know. Now, if I ask you how to find the I Norton, what is the way Mr. Norton had shown us or taught us? Anybody can tell me? How Mr. Norton told us how to find the I Norton? What to do? AB terminal.
The short circuit.
Short circuit.
AB terminal.
Excellent. That is the thing, straightforward. And then AB terminal short circuit will be I short circuit, which will be I Norton. That's what the whole class today I told you. And you have to find it. Full stop. Clear? Hey, I told you to open the speaker
Yes, sir.
and then
Yes.
take another mobile to talk, girlfriend. No, you answer my question. Okay, here, if you want to find it, then first thing first, if I ask you, what will be the short circuit? Yes, what will be the short circuit current? Can you tell me? Anybody? You first understand when you go for short circuit, this thing, this 25 ohm resistor will be redundant. There will be no current flow through this. True or not?
Yes, sir.
Yes, sir.
True, sir.
If this is true, then what will be the short circuit current in that case? All the current will go through the short path. What will be the all the current?
Minus 20 I.
Absolutely. Any children could not understand? Are there anyone? Minus 20 I. Hey, all of you got it or not?
Yes, sir.
Good. So this is minus 20 I. What we can write. Naushin, are you in line with me? Understand what is
Yes,
going on?
sir. There's some noise. That's why I turned it off.
Okay, no problem. So it's all right. Thank you very much. But to keep in touch, if you have any question, you ask me. Minus 20 I, you are writing here because all the minus 20 I current is flowing through this way and come back to this way. No current is flowing through this circuit. So it is minus 20 I, but the current is in opposite direction. So minus 20 I. Good. Now, minus 20 is okay. What is the I value? That is the question now. And I will coming from here. Right. Now let us go for finding the value of I. Can anybody tell me what is I now? Oh, I'm sorry. One thing you should remember over here. When you find the, I forgot to tell you, you note it down. When you find the R Thevenin, then what happened? All, remember, all the, okay, all the, not all. It is not the method. You can go for it, no problem. Okay, what will be the No, I'm sorry. What will be the R Thevenin? I'm sorry, I equal to from this circuit. What is the voltage here?
5.
Sir, V
Five.
minus 5
5
minus
volts.
3V.
Yes,
The two
that's what
source.
I'm talking about. 5 minus 3V, right? Can you tell me what is V equal to in this circuit? Anyone? V is the voltage across 25 ohm resistor, right?
Yes, sir.
So what will be the V?
So
Oh.
minus 5 volt.
Okay, minus 5 volt. V equal to minus 5 volt. Are you okay? Look at it. This is 25 ohm resistor. The voltage is V. And what is the current?
20I.
You kill
Minus
yourself, man. What is the current flow through 25 ohm resistor? Is it 25I? You short the dark. Why I put the cross sign? Because
No current flow.
no current flow. Short circuited, no current flow. So what will be the current go through the 25 ohm resistor? What will be the current?
0.
0. If it is 0 ampere current, what will be V equal to? Ohm's law. Hey, we forgot Ohm's law.
V would be 0.
Yeah, 25 ohm is the resistance. Current is 0 ohm, 0 ampere. Voltage will be I into R. I is 0, R is 25. What is the answer then?
0.
You understand it? The voltage across 25 ohm resistor will be 0 volt. Hey, anybody got question?
No, sir.
Somebody said 20I. How come you said 20I? Because you short circuited. All the 20I go through the short circuit path. No current is flowing through the 20 ohm resistor. So the voltage is 0, isn't it? Hey, you understand it?
Yes,
Yes,
sir.
sir.
If it is 0, then you say 3V. Will it be 3V? It will be what? V equal to what?
0.
Right. V equal to 0. If V equal to 0, listen, if V equal to 0, the whole voltage source will be 0. Voltage source 0 means what to do? You have to make it what? Open or short?
Short, sir.
Good. So that it is 0 volt. 3V means 3 into 0, right? Hey, 3V means what? 3 into 0.
0.
3 into 0, 0 volt. So it is short circuited. That's the way deactivation, you know, that voltage source. So this is short circuited. And short circuit means this value will be 0 volt. So because directly ground. And this is 5 volt. So 5 volt minus 0. So y equal to what?
5 by 2000.
5 minus 0. Is it minus 0? You should write. Otherwise you cannot understand, isn't it? Sir, 5 minus 0. Otherwise I cannot understand. Is it? Now what is the answer? Okay, I'm writing it 5 by this thing as it is, no problem. But all what, hey, you understand it, please?
Sir.
Okay, good. So what would you do? This I, you have to substitute here. If you substitute here, what is the answer you get? Now you substitute this value. This value is what? This value
So
is
minus
I.
0.05.
Yeah, 0 to 1000, ting, ting, ting. That means if your 2020 is giving you 100, right? Okay, you are getting here what? You're getting here minus what? Can you tell me? Minus?
0.05.
0.05.
Okay, I'm writing here 5 by 100. Let's say like this. I short circuit or I Norton. You can say this is I short circuit or I Norton equal to this value. Okay, 0.05, whatever you write. Now, all this, what you have to do is this I Norton, you have to substitute here. And if you substitute here, what you get? What is the answer? R Thevenin equal to then 0.0 dang dang. You put the dang dung, whatever. What you call that 5 divided by 100. You put the value and then find the R Thevenin. What you are waiting for me, I'll do, and then you copy.
100.
Too much
100,
dependent
sir.
on
100.
copy paste. 100. So 100 is a 100. In the midterm also you have applied the same thing. Okay, so what happened? 100 ohm. So this is your R Thevenin. Isn't it very easy? Yes, sir. So R Thevenin, you get it. Now you back here. Now you put the answer here, get full marks. This is your R Thevenin, which is 100 ohm resistor. So 100 ohm you get here and 5 volt. This is the complete answer to this question, R Thevenin and E Thevenin. You understand it?
Yes, sir.
Yes, sir.
Hey, rest of you, okay, good. And if I say, hey, what is the Thevenin equivalent? I'm sorry, what is that? Norton equivalent. Then what you do, you first find the Thevenin equivalent like this, and you can convert it into Norton equivalent, like the source conversion. If I ask you this question, then you can easily find the Norton equivalent, I Norton, and this is the Thevenin. And it's straightforward. You can say this is what? This is 100 because R Thevenin, Norton Thevenin is same. This is 100 R Norton, and only the current source. Current source is up arrow, and 5 into this is also 500, right? 500. Sorry, 5 divided by 100. Minus 5 divided by 100 minus 5 divided by 100, the 0.01 ampere. So this is your Norton equivalent. If the question says that find the Norton equivalent, then you can also find it in this way. Find Thevenin equivalent as well as Norton equivalent. Then once you find the Thevenin, then you can also convert it into source transformation like that way, or you know the relationship from there you can find. That's okay, no problem. This is not necessary here, but I'm just talking about that can be done also. Because why? You look at it. The question we have, Ting Tang, look at it. This question. Hey, can you see this question?
Yes, sir.
Yes,
Okay.
sir.
What this ask for? You have to find Thevenin equivalent. You have to find also Norton equivalent for this question. Okay, you do it by yourself. Exactly the same question. So it's a dependent source is there. So you have to first find the Thevenin equivalent plus minus V Thevenin and R Thevenin. R Thevenin. First thing first, you have to go. Which one? You find first VAB, EAB or E Thevenin first, and then R Thevenin you have to find. After that, after finding this E Thevenin, R Thevenin, and then you know that how to do it. Now I don't need to tell you again. Exactly the same way you have to follow, and you find it, and then you can find the Norton equivalent from the Thevenin equivalent. It's not like that you have to solve it again. Once you get the R Thevenin and E Thevenin, then you can go for the Norton. Norton means what? E Thevenin divided by R Thevenin, and this is R Thevenin or R Norton. So you can easily find from here once you get it. That's why I show you there in this question that Thevenin equivalent. If you ask Norton also, you can do it. Now, can you solve this problem exactly the same way? Are you sleeping?
No, sir.
Yes, sir, or no, sir?
Yes, sir.
Yes, sir.
Good. So you try, and next, if cannot, then 15 minutes earlier, if you come, then I can show you how to solve the problem. I think it's a very similar, very simple problem. You can try your best, and I will solve it if you cannot. Now I'm going to finish it. Just you see the thing. Today I have given you some, this is question, lecture 12. So practice problem, if you look, I have given today, Thevenin, oh no, sorry. Practice problem with Thevenin. What is this? No, these are practice problem on Thevenin dependent. Yeah, look at this gut. Two problems are very important. You can just solve it. Can you see the problem here? Is having a dependent source are present here, and you can solve. Here also same problem. You can see this dependent source is there. In both cases, it's a Thevenin R Thevenin is asked to found, but you can check the answer. And also Norton you can also find from the Thevenin R Thevenin. So these two problems are very similar type of problem, and I assume all of you can solve this problem. I think that is the end of the game. So that's what we have already discussed about today was our target of these things. So problems with dependent sources done. So our all problems solved for Norton and Thevenin. Norton and Thevenin is completed. Both lectures I will upload, and you can go through both lectures. But remember, no more class on this Norton Thevenins. It is the end of it. And next class, we are jumping to the next topic. And practice problem you try to solve, and in the next assignment too, you are ready to solve the Norton Thevenin's problem. Next class will be lecture 13 will be on maximum power transfer. Maximum power transfer is the continuation of this Thevenin equivalent, remember. After Thevenin equivalent, then we are going to find out how to transfer the maximum power. So Thevenin equivalent and maximum power are another handshaking two theorem. So a problem you can see in future is this Thevenin theorem and maximum power transfer are combining together into one problem. So that problem I already uploaded in lecture 13. If you download the lecture 13, you can see all the practice problems are the combination of Thevenin's theorem and maximum power transfer together. Your brain, your antenna could not catch what I told you, right?
No, sir.
No, sir. Absolutely great answer. If you say yes, sir, something may be wrong. Good, absolutely correct. Now I think next class in lecture 13, it will become clear to you. So you don't need to think about it now. And in that case, I suggest you not to download lecture 13 practice problem now. Then brain will be short circuited. After finishing lecture 13, then you download the practice problem and you can see what I told you. Then you understand it. Good. As you said, no means you are in full concentration with what I am telling you. Great. I think that's end for today's class. You please try to solve the practice problem in lecture 12 and lecture 11, what is already uploaded. I think you can easily solve it, and you can also solve the assignment 2 problem. Remember, this will be included into assignment 2. Yeah, any question? Otherwise, the class is ended officially, so you can ask question. You can stay back, those who have questions.
I have one question from the practice problem, Thevenin's equivalent theorem. Sir.
Okay, I will solve the problem now, but I'm just telling you, if somebody might have a class, that's why I'm telling those who have class or something like that, you can go, because officially the class is ended, so you can go. And those who are having time, you can stay back for discussion or any other thing. Okay, thank you very much for staying with me until the end of the class. Thank you very much.
Thank you.
Okay. What is your problem? Tell me.